As you can see, this is lots of odd facts and figures about our neighbours in the solar system. They're lined up there in all distance from the sun. And the one on the far right, I don't know, anybody can guess what that is?
Two eggs,
joke.
2 fried eggs.
Yes, it's Planet X. But yeah, the rest of it is on a more serious note, more academic note. Is Our Odd Neighbours, 10 things you may not know about our solar system, plus a few more actually, plus quite a few more. But before I start on today's talk, just a few words on a This Day in History theme, an event which took place on the 8th of February, 1672, when Isaac Newton's first optics paper, his new theory about light and colours, was read before the Royal Society in London.
Hello.
Newton having been elected a fellow a month earlier. From his earlier work, observing the spectrum of colours exiting a prism, he concluded that the lens of any refracting telescope would suffer from the dispersion of light into colours, what's called chromatic aberration. And as a proof of the concept, he constructed a telescope using reflective mirrors instead of lenses to bypass that problem, and presented it to the society, the telescope that is, in 1671. So we're talking about what, 350 years ago, odd, just about. But now on to the talk. The solar system that we live in is a bizarre place with its alien planets, its mysterious moons and strange phenomena, some of which are so out of this world that they elude explanation, including flyby missions. If you want to put up slide 2, Owen, at this point. Thank you, including flyby missions, spacecraft have visited every planet of the solar system. We've been exploring space for more than 60 years, and in that time, 36 probes have actually reached the surface, or at least deep into the atmosphere, of all the planets except Uranus, Neptune, and Pluto, accepting that the latter is a planet for the purposes of this talk. The vast majority of those probes have successfully transmitted data back to Earth, 21 of them from the surface of the target planet. Venus is the most visited one, 18 times, and then Mars, 14 times. The Moon, our nearest neighbour, has received an astonishing 48 probes. So if you thought the face of the man in the moon was looking increasingly painful, now you know why. 6 of the landings were, of course, manned missions in the Apollo program, starting with Apollo 11 on the 20th of July, 1969. If you've read those facts now, you can move to slide 3 about the moon. And starting with our nearest neighbour, despite its appearance in the night sky, our natural satellite, the moon, is nowhere near round. In fact, the moon is shaped more like a lemon, with flattened poles and bulges on the near and far sides around its equator. This obviously is an exaggerated picture, but on the right is the dark side of the moon, and on the left, the side that faces us. We don't see these equatorial bulges, of course, because the near and far faces of the moon always face towards and away from us, because the moon is tidally locked to the Earth. Many objects in our solar system have a bulge around their midsections, caused by their fast rotations that tend to fling material outward at equatorial latitudes, that is, around the axis of their spin. but our moon's rotational bulge is about 20 times larger than was expected. An equatorial diameter that would be, if you averaged out the heights and depths of the moons and basins or mares, about 200 meters longer than its diameter through the poles. And the bulge is greater, as I said, on its earth-facing and dark sides. This strange shape is thought to have been created during interactions with Earth soon after its formation. In the early solar system, the moon was closer to the Earth. It was spinning much faster than now and contained more water within its structure. These factors are thought to have caused the exceptional bulge over several 100 million years. But as the sun's radiation output was about 30% lower then, the bulging process largely froze about 4 billion years ago. Moving to slide 4, which is Mercury. That's moving inwards towards the center of the solar system. The nearest planet to the sun, Mercury, is still shrinking. For many years, scientists believed that Earth was the only tectonically active planet in the solar system. But that changed after the Messenger spacecraft did the first orbital mission to Mercury, mapping the entire planet in high definition and getting a look at the features on its surface. Messenger, by the way, is an acronym for the Mercury Surface Space Environment Geochemistry and Ranging Project. On slide 5, one of the details that was picked out by that mission, this shows fault scarps on Mercury. In 2016, data from Messenger, which had crashed into Mercury as planned a year earlier in April 2015, revealed cliff-like landforms known as fault scarps. These features are common on Earth and usually occur where one geological system abuts against another. Over geological time, or sometimes catastrophically causing earthquakes, the different systems move relative to each other, either vertically or laterally. Alderley Edge in Cheshire is a well-known example in this country. Because Mercury's fault scarps are relatively small, scientists are sure that they weren't created that long ago in our sort of astronomical history terms. But the planet is still contracting 4.5 billion years after the solar system was formed. The timing of Mercury's days and years can be difficult to understand because a day on Mercury lasts twice as long as its year. Technically, one Mercurian day, that is the time that it takes to rotate once on its axis, lasts 59 Earth days, while a year, the time it takes to orbit the sun once, lasts 88 Earth days. Now, by that definition, a Mercurian year is about 1.5 Mercurian days. But due to Mercury's very eccentric orbit and its alignment with the sun, the length of time from sunrise to sunrise, which is known as a solar day, is equal to 176 Earth days. And that is twice as long as the Mercurian year of 88 Earth days. Moving further out from the sun to slide 6, we've got Venus. And Venus is a most hellish planet with a high temperature, high pressure environment on its surface. 10 of the Soviet Union's 14 heavily shielded Venera probes lasted only a few minutes on its surface when they landed there in the 1970s. But even above its surface, Earth's sister planet has a very bizarre environment with a super rotating atmosphere that whips around the entire planet once every 4 Earth days, scientists have found that its upper winds flow 50 times faster than the rotation of the planet itself. Venus, though, is the slowest spinning planet, taking 243 Earth days to complete one rotation, its own day. And the European Venus Express spacecraft, which orbited the planet between 2006 and 2014, tracked the winds over long periods and detected periodic variations. It also found that the super hurricane force winds appeared to be getting stronger over time. Observations by the orbiter show average cloud top wind speeds rose 33% between 2006 and 2012, from 186 to 249 miles per hour. The next slide, slide 7, gives an artist's impression of sunrise on Venus. And you can see volcanic lava flows there. You can see the toxic clouds in the atmosphere and the hazy sunrise in the background. Like a wayward sister, Venus also rotates in the opposite direction to most of the other planets, including Earth, spinning clockwise rather than anti-clockwise, which means that the sun rises in the west and sets in the east. There are two theories why this is so. The first is that due to the huge gravitational effect of the sun on Venus's dense atmosphere, it flipped over at some time in its history. In other words, it spins in the same direction it always has, just upside down, so that looking at it from other planets makes the spin seem backward. The second theory is that its rotation slowed to a standstill gradually and then reversed direction. There is one other planet in our system that spins oddly, and to see if you can guess which planet it is before we get to it, without Googling it, that is, Eileen. Some more facts about Mars, going to slide 8. Mars has the biggest volcano that we know of, and it also has the longest valley. While Mars seems quiet now, in the past, something caused gigantic volcanoes to form and erupt. This includes Olympus Mons, which I'm sure you've all heard of, the biggest volcano discovered in the solar system. And that one is shown in more detail on the next slide, slide 9. At 374 miles across, the volcano is comparable to the size of Arizona. It's 16 miles high, which is 3 times the height of Mount Everest. By comparison, Hawaii's Mauna Loa, the tallest volcano on Earth, rises 6.3 miles above the seafloor, although its peak is only 2.6 miles above sea level. The volume contained by Olympus Mons is about 100 times that of Mauna Loa. And slide 10 will give us sort of a comparison of the sizes of those 3 features. Volcanoes on Mars can grow to such immense size because gravity is much weaker on the red planet than it is on Earth. But how did these volcanoes form in the first place? There is a debate as to whether Mars has a global plate tectonic system and whether it is active. Olympus Mons is called a shield volcano. Rather than violently spewing molten material, shield volcanoes are created by lava flowing slowly down the sides, so that the mountain has a low, squat appearance with an average slope of only 5%. 6 collapsed craters, or calderas, stack one on top of another at the top of the volcano, to create a depression at the summit that is 53 miles wide. As magma chambers beneath the calderas emptied of lava, probably during an eruption, the chambers collapsed, no longer able to support the weight of the ground above. Further out towards the edges of the volcano, if you want to go back to slide 9, Owen, you can see the one after that, sorry, the one showing Olympus Mons. That's, you can see surrounding the volcano a distinct cliff, which it's an escarpment which surrounds the complete outer edge of the volcano, and it's as high as 6 miles above the surrounding area, which is a wide depression due to the immense weight of the volcano pressing into the crust of Mars. The absence of tectonic plates may play an important role in the different kinds of volcanoes. The hot spots of lava under the crust remain in the same location on both Earth and Mars. But on Earth, the movement of the crust prevents the steady buildup of lava. Chains of smaller volcanoes occur as tectonic plates move over the hot spots. But Mars has very limited plate movement, and when lava does flow to the surface, it continues to pile up in a single spot. Instead of a chain of volcanic islands, as on Earth, large volcanoes such as Olympus Mons will form. The term the red planet is actually a bit of a misnomer. A variety of colors can be seen in its surface, including the predominant rusty red-brown of the planet that it's known for. This rusty coloring is from iron oxide, just like the rust that forms on Earth when iron oxidizes, often in the presence of water. Some places on Mars are bright white with ice or silica deposits, and other places are any of a wide variety of colors between white and rusty brown. This array of colors is a result of mineral diversity, just as on Earth. In images of Mars, some regions appear to have different colors because of shadows or reflected sunlight or even seasonal changes, such as the appearance of permafrost and flow features. Moving to slide 11 now. This is one, and the next one again. That's it. This is the Valles Marines on Mars. If you thought the Grand Canyon was big, it's nothing compared to Valles Marines. At 2,500 miles long, this immense system of Martian canyons is over 10 times longer than the Grand Canyon on Earth. Despite its size, it's about as long as the United States. That's across the latitudes. Across the lines of longitude, as wide from the east to the west coast. Valles Marines escaped the notice of early Mars spacecraft, which flew over other parts of the planet. But it was finally spotted by the global mapping mission Mariner 9 in 1971. We'll move out now to the 5th planet from the Sun, Jupiter, on slide 11. And that slide, besides the facts, shows all the different cloud belts, plus, of course, the famous great red spot on Jupiter. Jupiter is a massive gas giant, 2.5 times more massive than all the other planets in the solar system combined. It is the fastest spinning planet in the solar system. Like its neighbor Saturn, it has rings, and its magnetic field is 14 times stronger than Earth's. It also has between 53 and 79 moons, depending on how you define a moon. Some of them are just small icy bodies that are parts of its ring system. And of course, it has a great red spot, a huge anticyclonic, that is high pressure, storm system between its bands of counter-rotating cloud structures. Despite its huge size, Jupiter spins on its axis once in only about 9.5 hours. The surface of Earth at the equator is rotating at about 1,000 miles per hour. But Jupiter's equatorial cloud tops are moving at 28,000 miles an hour. Unlike Saturn's rings, Jupiter's are thin and wispy. They're very dark and difficult to see. They're made up of small bits of dust from meteors striking the surface of Jupiter's small inner moons, which kick up dust, which then goes into orbit around Jupiter. Slide 13 shows Jupiter's, the inner part of Jupiter's magnetic field, the inner magnetosphere. It's the largest object, the magnetic field as a whole, including the inner and outer parts, is the largest object in the solar system. If it glowed in visible wavelengths, it would appear to us 2 or 3 times the size of the sun or moon. It's about 3.3 million wide, 3.3 million miles wide on average. And its magnetosphere is 150 times wider than Jupiter itself, and almost 15 times wider than the sun. Slide 14 shows the outer magnetosphere. And you can see in it, within it, the inner magnetosphere, and the outer magnetosphere is strong enough to deflect solar winds, as you can see at the extreme left edge of the slide. Of course, if the sun's magnetosphere was similarly visible, it would stretch 23 billion miles from the star, encircling all the planets in the solar system and much more beyond. Unlike Earth's relatively inactive moon, Jupiter's moon Io has a chaotic landscape with hundreds of volcanoes and is considered to be the most active moon in the solar system. If you go to slide 15, this will show a picture of Io. And some of these plumes erupt up to 250 miles into the atmosphere. Some spacecraft have recorded Io erupting, as you can see here, including NASA's Galileo craft in 1997 and the Pluto-bound New Horizons craft when it passed by in 2007. Io's eruptions are caused by the immense gravity that the moon is exposed to, as it's nestled in Jupiter's gravitational well. The moon's insides tense up and relax as it orbits closer to and further away from the planet, generating enough energy to maintain a molten core and volcanic activity, even though it is barely larger than our own moon, with a radius only 52.5 miles greater at 1,132 miles. Scientists are still trying to figure out how heat spreads through Io's interior, making it difficult to predict where the volcanoes exist using existing scientific models alone. We move out further now to Saturn, the 6th planet from the sun. Very familiar shot of the planet there on screen now. Saturn is the 6th planet from the sun and the most distant from Earth, and the most distant planet from Earth that can be seen with the naked eye. Saturn is also a gas giant. It also has many moons and also has its famous ring system. Being a gas giant, it only has 1/8 of the average density of Earth, but with its larger volume, Saturn is over 95 times more massive than Earth, with an average radius of about 9 times the Earth's radius. This means that it is also the flattest, you could even say fattest planet, with a polar diameter which is only 90% of its equatorial diameter. This is because of its low density as a gas giant and its fast rotation speed. It takes Saturn only 10 hours and 34 minutes to turn on its axis and causes oval-shaped storms similar to those of Jupiter. Saturn's equatorial cloud tops move at only 1/25 of the speed of Jupiter's, but that is still 1,118 miles per hour. And that's 4.5 times as fast as the strongest hurricane on Earth. At an average distance of 886 million miles from the Sun, Saturn's orbit of the Sun takes 29.4 Earth years. Because of its low density, being mostly composed of the light gases hydrogen and helium, if it were physically possible, you could float Saturn in water. At the most recent count, Saturn has 82 moons. 53 moons are confirmed and named, and another 29 are awaiting confirmation of discovery and official naming. Its moons range in size from the giant moon Titan, which is larger than the planet Mercury, to as small as a sports arena. This means that Saturn has now overtaken Jupiter as the planet with the most moons. But as yet, Jupiter has not submitted a legal challenge. Oh, I almost forgot the rings. They are 240,000 miles wide. That's the same as the distance from the Earth to the Moon. But Saturn's rings are as little as 100 yards thick in places, which is a width to thickness ratio of about 4.25 million to 1. Moving further out to the 7th planet from the Sun, Uranus, it appears to be a featureless blue ball on first glance, but this is also a gas giant of the outer solar system, and it's pretty weird on closer inspection. First, the planet rotates on its side, that is, about an axis that is nearly parallel with its orbital plane around the Sun. It is, in fact, of course, the other planet that spins in an odd direction. It's for reasons that scientists haven't quite figured out. But a new study suggests that Uranus was tipped on its side by a succession of impacts rather than a single blow, as was previously thought. This finding sheds light on the early history of Uranus and its 27 moons. It could also force astronomers to rethink their ideas about how the solar system's other giant planets formed and evolved. The standard planetary formation theory assumes that Uranus, Neptune, and the cores of Jupiter and Saturn formed by accreting only small objects in their protoplanetary disks. They should have suffered no giant collisions. Its tilt makes Uranus unique among the solar system planets. Its spin axis is tilted by a huge 98 degrees, meaning that it, as I said, it essentially spins on its side. And no other planet has anywhere near such a tilt, although Jupiter is tilted by 3 degrees, the Earth by 23.4 degrees, and Saturn by 26.7. Uranus also has tenuous rings, which were confirmed when the planet passed in front of a star from the Earth's perspective, in 1997. As the star's light winked on and off repeatedly, astronomers realized that there was more than just a planet blocking the star's light. More recently, astronomers spotted storms in the Uranian atmosphere, several years after its closest approach to the sun at 1.8 billion miles, when the atmosphere would have been heated most. Moving out one planet further to number 8, Neptune. It's the 8th and most distant of the recognized planets. It's the smallest of the gas giants, with a surface gravity which is almost Earth-like, about 1.2 times Earth's gravity. But there the similarity ends. The 4th largest planet by diameter and the 3rd largest by mass, it is 17 times as big as Earth and slightly more massive than its near twin Uranus. Neptune has the coldest average temperature of any planet in the solar system at minus 214 degrees Celsius. But although it is 1 billion miles further from the sun than Uranus, the lowest planetary temperatures recorded was on Uranus at minus 224 degrees Celsius. That's because at such distances, the sun has little effect on the temperature of the planets. Any heat is mostly caused by the motion of the planets themselves and their interiors, which is where the differences lie. Neptune has rings too, but it also has the strongest winds in the solar system, with speeds near 1,200 miles per hour, near the older Great Dark Spot, which is the one near the bottom of the photograph there. The equatorial regions of Neptune possess average winds of over 700 miles an hour, which is still faster than the speed of sound here on Earth. The cold temperatures might decrease the friction in the system, enabling faster winds. But more importantly, Neptune radiates 2.61 times as much energy as it receives from the sun, and this is enough heat to help drive the fast winds. The predominant blue color of the planet is a result of the absorption of red and infrared light by Neptune's methane atmosphere. Clouds which are elevated above most of the methane layer appear white, while the very highest clouds tend to be yellow-red. More than 30 times further from the sun than Earth, Neptune completed its first 165 Earth-year orbit since its discovery in 1846, as recently as 2011. Now we move out to Pluto, slide 19. And Pluto, as the small sort of inset photograph shows, it is quite a tiny world at the edge of the solar system. It's less than 1,500 miles in diameter and an average distance of 3.7 billion miles from the sun. It was the first and the largest Kuiper belt object to be discovered. That's the ring of objects which orbit the sun beyond the orbit of Pluto. It was discovered in 1930 and is arguably really just a Kuiper belt object, like the other bits of rock, ice, comets, and dwarf planets, rather than a distinct 9th planet. So at first, it was thought that Pluto would have a fairly uniform environment. That changed when NASA's New Horizons spacecraft flew by there in 2015, sending back pictures that altered our view of Pluto forever. Among the discoveries were icy mountains, 11,000 feet high, including ice-spewing volcanoes, indicating that Pluto must have been geologically active as little as 100 million years ago. But geological activity requires energy, and the source of that energy inside Pluto is a mystery. The sun is too far away from Pluto to generate enough heat for geological activity, and there are no large planets nearby that could have caused such disruption with gravity. So I'll finish the talk with a question and a mystery. If that energy came from massive impacts billions of years ago, early in Pluto's formation, how has it endured so long in a small icy body so far away from the sun? Thank you. So